Now, we got different approaches in probability. I could remember the other time I introduced you to the meaning of probability. The probability is just a measure of likelihood occurrence of an event. A measure of likelihood occurrence of an event. Okay. Now, with different, mathematician or statistician, different scientists in general they got a different view of probability. Now, the first one is what we call subjective approach. Now, what do we mean by subjective approach? The subjective approach is not like a judgmental approach. We are in this approach, we actually use the past experience, to judge a situation. For instance, I think you guys know Mike Tyson. Mike Tyson happens to be former heavyweight champion in boxing. Is there anyone who have heard about that name, Mike Tyson?
Yes, sir.
Okay, thank you for that. Now, this guy is a professional boxer. Now, let us assume that I decided to confront Mike Tyson today. Okay, maybe I just announced to you, the student, that, okay, you know what, my student, I want to confront Mike Tyson, or I want to confront a professional boxer. Definitely, I think you guys know the results even before the fight. So, what are you using? You are actually using a subjective approach. You are not giving me all the chance because you know that I'm not a professional boxer. Of course, the Mike Tyson is actually going to carry the day. So when we talk about subjective approach, so what subjective approach is actually talking about, we're using the knowledge, we're actually using past experience to judge, the performance, to judge what is actually going to happen. Okay. Now, um, let me just give you this scenario. You know, I told you the other time that when you want to figure out probability, you need to first state your sample space. What is sample space? Sample space is a collection of possibility. The collection of possibility. Okay. Now, you know, based on the example I cited, it means in my sample space, I'm actually going to have win, lose, okay, in my sample space, because I said I want to go and fight Mike Tyson, which means there are two possible outcomes. Okay, it's either I win or I lose. Those are the elements in the sample space. Now, by subjective approach is trying to tell us a particular element in the sample space has a very higher probability of occurring than others. It means the probability of Mike Tyson winning the fight, okay, the probability of winning is actually higher than probability of losing because it happens to be a professional fighter. Why the probability of losing is very, very high. Okay, so that is the reason why we said it is an estimate that reflects a person's opinion, okay, or best guess about whether an outcome will occur. Okay, so when you have in a situation where you have an opinion, you got a very strong opinion, and the opinion you have is actually based on the past antecedents. Okay, so and that's exactly what we mean. And you know what? Subjective approach is highly recommended in medicine. You know, a doctor that want to treat a patient must have experience, okay? Must be able to have something in mind that may likely be wrong about the patient. A doctor should not be complete novice of the situation. Now, take a look at it. That's why I said important in medicine. And it formed the basis of a physician's opinion based based on information gained in the history and physical examination about whether a patient had a specific disease. So, which means, a philosopher said, and I quote, uh, a mind can never be empty. We're always going to have something in mind, okay, about situation. Okay, you remember I told you the other time that our idea of how things work actually produce a model. You know that? The idea of how things work, it means we actually have something in mind. So in most of the situation, we normally use subjective approach. So on a final note, the subjective approach is trying to tell us that elements in the sample space are not equally likely. I'm going to say that again. Elements in the sample space, or let me say outcomes in the sample space, are not equally likely. It means some outcome have greater chance of occurring than others. That's what we mean by subjective approach. Okay. Um, the next point of call. Uh, Give me 1 second. Okay. So the next point of call is what we call the classical approach. Okay. And let me tell you what is the meaning of classical approach. I'm still going to use, if I want to talk about probability, like I said, I need to have a sample space. And what do we mean by sample space? Sample space is a collection of possibilities, okay? The collection of possible outcome. Now, when I talk about classical approach, the classical approach assume that all outcomes in the sample space are equally likely. What do I mean by equally likely? It means what that approach is saying that if I want to go and fight Tyson today, anybody can win. That is what the approach is talking about, equally likely. And that may not be true. There are situations where equally likely could be true. There are situations where equally likely is not going to be true. So in the class, and that applies to tossing a coin. If you take a look at a coin, we got two sides in a coin, right? When you flip a coin, any side can, the probability of a tail coming up is the same thing as the probability of a head coming up. Okay. And when you take a look at, so that kind of, situations can be referred, the classical approach could actually work. Okay. So I'm going to say that again. In the classical approach, we believe that elements or outcomes in the sample space are equally likely. And which means this is going against the subjective. Because what subjective is talking about is that, some outcomes in the sample space, have greater chance of occurring than others. There is nothing like equally likely in a subjective approach. But in classical approach, then there is no element, there is no outcome in the sample space that have a greater chance of occurring than others. Does that make sense to everyone? Or is there anyone who need clarification before I go ahead? Is there anyone? Is there anyone? Does that mean you guys are good, right?
I actually have a quick question. So this
Okay.
classical approach is only when it's equally likely for both outcomes, or like if there's three outcomes, would it be like a third chance for each?
Yeah. If
That's
it is three outcome, then it's going to be a third chance for each.
okay.
If you have 100 outcome, then it's going to be 1/100 for each. Does that make sense?
Mm-hmm.
Okay. Good job. Good question. Now, let me tell you this. You know, I talk about a coin right now. I said the probability of a side showing up in a coin, because I'm talking about two fair coin, two-sided coin, the probability is 0.5. But you know what? Somebody may argue that with me and say, no, how am I so sure that it's 0.5? How am I so sure it's half? Somebody can decide to say, okay, let me toss a coin. I'm going to toss a coin 10 times, and I'm actually going to see for myself whether the probability of any side showing is equal. Okay, now the person can decide to say, okay, can toss a coin first time, maybe head shows up, second time head, third time head. There's possibility that when you toss a coin 10 times, you could see 8 heads. And when you see 8 heads, then that means the probability of a head showing up is going to be 8/10. Is it not? Because you toss the coin 10 times, and the number of times head shows up is 8. And of course, going by the definition of probability, because it is a ratio of the number of outcome favorable to the experiment to the number of time an experiment is performed, you're going to say it's 8/10. And that is now going against theoretical assumption. But let me tell you this. There's what we call theoretical probability, and there's what we call experimental probability. Okay? There's what we call theoretical probability, and there's what we call experimental probability. The theoretical probability is what I just talked about, where that give equal chance to the probability that any of the side, the probability of an edge showing up is 0.5. That's a theoretical probability. Okay, now if I talk about experimental probability, is when I now perform an experiment with a coin that I decide to toss a coin. I want to see for myself. And in the example that I cited, maybe out of 10 tosses, heads show up 8 times. Then it means experimental probability is 8/10 in that situation. And don't forget that the theoretical probability is going to be 5/10, right? So which means experimental probability is going against theoretical. But let me tell you this. When you continue to have more tosses, then you're actually going to see that the experimental probability will converge to theoretical. On the long run, that's what we mean. On the long run, the experimental probability will actually converge to theoretical probability. And that's exactly what I'm trying to say here. I said, it is well known that the probability of flipping a fair coin, of course, is 0.5. Okay. We know, somebody said, is this a law of large numbers? You are right. Good job. Send a message to me for extra credit. Send a message to me. Good job. So if a coin is flipped 10 times, there's a guarantee that exactly 5 tails will be observed. But let me tell you something. That may not be guaranteed when the number of trial is small. But you know what? If the coin is flipped 100 times, if you continue to increase the number of trial, that was why I said as the number of flip becomes larger, the proportion of coin flip that results in tail will approach 0.5. So what am I talking about? It means on the long run, experimental probability will converge to the theoretical probability. Okay. The next thing that I'm going to talk about now is to walk you through an example. Okay, I want to walk you through an example right now. The example is on the probability of male versus female bats. Okay. Now, the long run relative frequency of main born in KSA, maybe in South Africa, is about 0.512. Now, 0.512 means 512 boys born per 1,000 bats. Okay. Now, this is the long run relative. Now, take a look at the table. that we have. The table provides result of simulation, okay? The proportion is far from 0.512 over the first few weeks, but in the long run, settle down around 0.512. This is synonymous with what I just talked about. Okay, the theoretical probability was 0.512, but when you observe, look at the first week. Can you say the first week? When the total birth was 30, the total number of boys was 19. And if you take a look at the probability, okay, if you take a look at the proportion of boys, the proportion of boys was actually 0.633. I think you can see that. And by the time we go to week 4, the proportion of boys was 0.586. You know, by the time we go to week, by the time you increase in the number of week, what happens eventually, okay? So what happens eventually, you're actually going to see that that we actually kind of converge, okay? If you take a look at what I have, give me 1 second. Now look at 52 weeks, you can see 0.517. Okay. Now, when I continue to go like that and increase the number of week of washing, of course, it's going to converge to a 0.512. And that was why I said, you know, uh, initially, the theoretical probability and the experimental probability may not be the same. But you know what? As time goes on, of course, it's actually going to converge. Okay, so I'm going to have now, assuming that an experiment can be repeated many times, and assuming that there are one or more outcomes that can result from each repetition, okay, then the probability of a given outcome is the number of times, that outcome occur divided by, what I just talked about is just that, okay, you know what, the probability is a ratio of the number of outcome favorable to the experiment to the number of outcome an experiment is performed. It means if I'm looking for the probability of success, the probability of success is actually going to be the ratio of the number of success divided by the number of trials. That's what we're talking about. Okay? Now, take a look at this problem right here. We got a problem group 0A, This is a blood group. Okay, and we collected for male, we collected for females. Okay, this table is being cross-tabulated. See that now? Now the 20 here is the number of males that have is blood group 0, and 20. It means male and female, the number of male and female that have the blood group 0 are equal. Okay, but when you look at blood group A, they are not the same. Or blood group B, they are not the same, and they are also the same as blood group AB. Okay, of course, the total number of males that I have is 50. Okay, and the total number of female that I have is 50. Can you see that now? Okay, then if you take a look at this particular blood group, you can actually see that right here, the total number of individuals with that particular blood group is 40. Okay, and the total number of individuals with blood group A is 35, and like that, and the total is 400. Okay, now if you take a look at that, so we can actually decide to determine, to ask probability questions in this table. Okay, so but let me tell you this: if there is no variation, we can't talk about probability, because when I talk about probability, it means I actually have I have variety. Okay, I have the varieties of stuff. Okay, and the probability is actually going to be focusing on a particular maybe on a particular outcome. Okay, and that is the reason why we say, okay, what is the probability of getting this, or what is the probability of for instance in the US Congress, okay, what is the probability of having a female in the US Congress? Of course, if I want to know that, then I need to know the totality, okay, of the number of people in US Congress and how many females do we have in US Congress. Therefore, the probability of female in the US Congress is actually going to be the ratio of the number of female in the US Congress to the totality, okay, to the number of the Congress men and women. Okay, so we can actually, in a situation, what I'm just trying to talk about is that in a situation where we got a partition, okay, of course a probability question is actually going to arise. Okay, now this is another example that we can actually talk about, where we're talking about the outbreak of food poisoning occurred in a group of students who attended a party. Okay, now uh we have a cross tabulation right here. Okay, those who ate barbecue and those who did not eat barbecue, and those who have the poison, and those who do not. Okay, of course, because we have partitions right here, because of that, of course, the probability question could arise. Okay, so I'm just trying to prepare your mind so that by the time we're doing that, you're really going to appreciate what we're talking about. Okay, now I want to take you through some stuff right now. We actually want to go more mathematical. Please, if there is anyone who doesn't understand, please, I want you to ask question, because we are in a foundation level now, because when the foundation of a house, when the foundation of a building is not strong enough, of course the building is not likely to stand. And that is the reason why please try and understand every notation. If there is a concept, if there is any area you don't understand, please signify by asking question. Now I want to talk about marginal probabilities right now. Now let me give you the idea of marginal probability. I'm going to take you back to the table right here. Take a look at this table. We got two major variables in this table. I'm going to say that again. We got two major variables in this table. We have the first variable is blood group, and the second variable is gender. I'm going to say that again. We got two variables in this table. Can you guys hear me?
Yeah, we can hear you.
Okay.
Yes.
Okay, thank you. I just want to be sure if you guys are hearing me very clearly. Now, if you take a look at this table right now, we got two major variables. One is the blood group, the other one is gender. But you know what? What is the nature of this variable? The first variable is categorical in nature. Categorical in the sense that blood group, has levels. How many levels of blood group do we have? 1, 2, 3, 4. Okay, so any categorical variable, we have more than one level. Okay, now we also have the gender is also categorical, and it has two levels, male and females. Okay, now let me tell you this. If you want to look at the relationship between gender and blood group type, I'm going to say that again. If you want to study relationship between gender and blood group type, of course, you as a researcher, you actually need to list possibilities. Okay, now I'm going to tell you this now. A variable, one of the quality of a variable is that a variable should be qualitative. I'm going to say that now. One of the quality of a variable is that a variable should be exhaustive, and it should be exclusive. I think I'm going to have a new share right now, so that I'm actually going to use my dashboard for those, my whiteboard. For those who may be having a trouble time getting what I'm trying to talk about. Now, can you guys confirm if you are seeing my whiteboard now? Can you see my whiteboard?
Yeah.
Yeah, it's all
Yeah.
good.
Yes.
Yes.
Yep.
Okay, thank you so much. Now, I'm going to write this because, when you are doing research, you actually need to identify variables and what is the nature of my variable. In fact, what are the quality of a good variable? So what I want to write right now, quality of a good quality of variables. Number one is exhaustive. Exhaustive. And number two, mutually exclusive. Now, number one, I'm going to explain exhaustive. I'm going to explain mutually exclusive. Now, what do I mean by exhaustive? Exhaustive means I need to have a list of possible answerable responses. I'm going to write that down. List of possible answerable responses. Now, what is the meaning of that? It means if I'm talking about blood group, I have to list all the types of blood group. Okay? That is what we mean by list of possible answerable responses. In that case, that particular variable is exhaustive in nature. Now, what do I mean by mutually exclusive? What do I mean by, a variable being mutually exclusive? Variable being mutually exclusive means that no two, there no a respondent cannot have two attributes simultaneously. It's either you belong to blood group A, or you belong to blood group B, or you belong to blood group AB. You cannot belong to, you cannot belong to blood group A and blood group AB at the same time. That is not going to be possible. You can't be a male and be female at the same time. And that is what we mean by mutually exclusive. So the mutually exclusive is actually trying to tell us, I'm going to put that there now, no respondent, no respondent should simultaneously have more than one attribute. More than one attribute. That's what we're talking about. More than one attribute. Okay? So these are the quality of variable. Okay? In the exhaustive means you need to list the all possible answerable responses. You want to ask question, right? From the respondents. Then you need to list all possibility of answerable responses. Okay? Now, somebody said I should specify what I mean by respondents. Of course, the respondents are those people that that are in our cohort, people that we want to use for our study. Okay? For instance, if I want to measure the blood pressure of my patient, then the respondents are my patients. Does that make sense now? So those respondents mean those who are responding. Okay? Those, I think I'm also going to call them in research, we call them observation units. Okay? We also call them subjects. Okay? I think that is clear, right? Okay. I'm going to go back to my share to the material right now, if you guys are good. Now, of course, what I have here, the gender is exhaustive because I've listed all possible gender. This is a male and female. And the blood group is also exhaustive. And you know what? There is no particular participants or respondents that should have more than one attribute at a time. It's either you are a male or you are a female. Or it's either you belong to this particular blood group or you belong to the other one. You can't be, you can't be in two groups at the same time. It's not going to be possible. Okay. So, okay. Now, I was talking about marginal probability the other time. I got two groups here. I got two variables here, the blood group and gender. But by marginal probability means, though I have two variables, but I want to sacrifice the other variable. I want to talk about one of the variables. I'm not interested in the two variables. That's what we mean by marginal. Now, you're going to take a look at that right now. You're going to see what I'm going to do right now. Now, for instance, I want to find the probability of male. If I want to find the probability of male, then it means I'm actually focusing on gender. Then if I'm focusing on gender, then it means I'm marginalizing blood group. Don't forget, we got two major variables, the blood group type and gender. If I'm interested in either male or female, then it means I'm marginalizing the other variable. Okay, take a look at this now. The probability of a blood group A. If I want to find the probability of a blood group A, then it means I'm actually marginalizing gender. It means I'm not interested in gender. Okay, now if you go back, if I want to find the probability of male, if I go back to the table, the probability of male is just going to be the ratio of the number of male to the total number of respondents. How many male do I have? I got 50, right? How many respondents do I have in total? That is going to be 100. Then what am I going to do? Then I'm going to do 50 divided by 100. And that is how to get, the probability. Look at that. So the number of male divided by total number of subject, then I got is 0.5. The same thing is applicable to the the probability of female. Okay. Now, if I want to get the probability of a blood group A, what I'm going to do, I'm going to go back to the table. How many people have a blood group A? This is A, then I'm going to go across how many people? That is 35. How many subjects do we have in general? We got 100 in general. And what is the probability this time around? It's actually going to be 35 divided by 100. Okay, and exactly. If I want to figure out the probability of, of being in AB blood group, then it's actually going to be, how many number do we have? That's going to be 10 divided by 100. You get it now? So, and that is the reason why, if you take a look at what we have for female, for male, for blood group A, and so on like that, that's exactly what you're going to do. Now, all what we have done are called marginal probabilities. Now, I want you to understand what I'm talking about right now. We can only talk about marginal probability when we have two variables. Okay? And we are interested in one of the variable. It means we're actually sacrificing the other one. Now, the next thing that I'm going to talk about now is conditional probability. Now, what we do in conditional probability is just how can we actually, determine the probability of one variable given the other variable. It means a variable is conditioning. Another word for conditioning is is depending. Okay, now take a look at this right now. And that was why I said this is a probability of an event on condition that certain criteria is satisfied. Okay, now if a subject was selected randomly and found to be female, what is the probability that she has a blood group 0? Now, please, I want you to take a look at this right now. If you want to answer this question in either in assignment or in test or in exam, please, we know formula is very, very important, because the way I grade, I don't grade final answer alone, but I grade method, your step, en route to the answer, en route to the result. Because somebody could get the result wrong, but he's still going to get reasonable grade if the step is okay. Okay, and that is the reason why in research, though we cherish about result, but we cherish more the method that lead to results. Okay, now look at what I want to do right now. He said if a subject was selected randomly and found to be female, look at that, found to be female. I'm actually, if I want to write that found to the female, it means that existed first. Okay, that was why you see the female down here. Now, I've said, okay, what is the probability that she has a blood group 0? The blood group 0, that what it just talked about will be at the numerator, will be at the top. Why? What existed? Because it said if a subject was selected randomly and found to be a female, look at that, found to be a female, that will come first. That will be at the bottom. Okay, because I realized that my experience in teaching probability, I noticed that some students normally switch that. And when you switch that, you're not going to get it right. And that's why you need to interpret, very well. Now, you're going to put, that at the bottom, and you're going to put what they just talked about here. Can you see that now? Now, if you want to figure that out, there's a particular formula here that is missing that I did not write. If you have a pen right now, you can actually write the formula down. Now, if I want to write, if I write the probability of O, or blood group 0 given F, that would be equal to the probability of, O intercept F divided by the probability of female. I'm going to say that again. Okay. Now, how do I arrive at 20? I arrive at 20 because the 20 is a number at the point of intersection of the two variables. Now, let's take a look at that. How many, let's go back to the table. We want to look at female and blood group 0. This is female, right? This is blood group 0. This is a 20 that we're talking about. Now, this 20 is a number at the point of intersection of the two variables. I'm going to say that again. That number is a number at the point of intersection of the two variables. Okay, now that is 20. That's what I'm going to put at the top. Okay, can you see that now? Then the one I'm going to put in the bottom is going to be the probability of a female. Okay, if female exists, the probability of a female exists. And what is the probability of a female? The probability of a female, you're actually going to look at the number of female we have divided by the totality. Now, let me tell you right here, this is 20 divided by 100, and right here is 50 divided by 100. 100 cancel out 100, and that was why you have 20 divided by 50, and that was why you have that. Okay? Now, that is how to figure out conditional probability. Okay? Can you give me 1 second? I just want to check. Okay. Okay, so, okay, we have like 8 minutes to go. Okay. Just trying to manage my time. Okay. Now, that is how we got that, okay? Now, the next thing I want to talk about is what we call joint probability. And what do we mean by joint probability? The joint probability is the probability of occurrence of 2 or more events together. Now, let me tell you, I'm actually going to have an extended class today, but for those of you who have lectures by 3:20, you can actually opt out of the meeting. But I'm still going to, because I want to make sure I finish this material. And you got nothing to lose. There's going to be an office hour on Tuesday for those of you who want to meet with me during the office hour. So, because I'm going to have an extended lecture today, but you can opt out of the meeting if you have lecture by 3:20. Thank you. Okay. Now we are under joint probability right now. And when we talk about joint probability, of course, we are trying to say the probability of occurrence of two or more events together. Okay. It's just like we're trying to look at the probability of doing two things together. Oh, that guy is a basketballer. Oh, that guy also play football. Oh, this guy has a skill, he can play football, he can also play basketball. Okay, we got event that can actually occur together. Okay, now if we want to look at an example based on what we have done, find the probability of being a male and belonging to a block group AB. Please, I want you to look at the way this question is asked. This is different from the way the question was asked under conditional probability. In the conditional probability, you're actually going to have a word given. But when you are talking about joint probability, you're actually going to have a word hand, A-N-D, hand, A-N-D. Oh, what is the probability of being a male and belonging to a group AB? Okay. Now, if I want to do that, it means I'm actually want to do what is the probability of being a male and I belong to that group, that blood group. And of course, mathematically, if I want to write that mathematically, okay, this is a statement. If I want to write that mathematically, and in mathematics, we actually bring this kind of sign. That's a notation for joints. We also call that intersection. Mathematics is very easy. But the only thing we need to learn about is, okay, I need to play around notation. Do I understand what a particular notation stands for? Okay. Now, if I have that, then I can go back to the table. When I go back to the table right now, what I want to go and check is just to check a particular value at the point of intersection. Now, we're talking about male and blood group AB. Now, you're going to see that now. Okay, this is male and blood group AB, that's going to be 5. Then 5 divided by what? 5 divided by 100. When you want to find probability, is going to be the number of characteristics of interest divided by the sample space, the totality. The totality is 100. And that was why you actually have 5 over 100. And 5 over 100, of course, is going to be 0.05. Now, there's something I also need to tell you. You can leave your probability in terms of fraction. You can leave your probability in terms of decimal. And you can also leave your probability in terms of percentage. So right here, this is more or less like a 5%. And what that 5% is trying to say is that, okay, 5%, of people that, of male, if you look at that now, you're going to see those who are male and they have a blood group AB is just 5% of the totality. Does that make sense to everyone? Okay, thank you for that. Now, we have been getting probability values. What are the possible range of probability? Okay, now the probability range between 0 and 1. But let me tell you something. In reality, probability cannot be equal to 0. and probability cannot be equal to 1. What happened in reality is something that is greater than 0 but less than 1. But in theory, okay, probability can be 0 and 1. But in reality, probability cannot be 0 and cannot be 1. Those are extreme probability. When probability equal to 0, then you are trying to say it is not sure. The event is not going to occur. When probability equal to 1, then you are trying to say very sure the event is going to occur. That is not going to be possible under this heaven. You know why? Because we live in a stochastic world. We live in a world where we don't have 100% confidence in any situation. Okay? And of course, if the probability equal to 0, you say it cannot occur. We don't say it cannot occur. Okay? And you know what? The sum of probability is equal to 1. Okay? The sum of probability equal to 1. Take a look at that. And when I say the sum of probability equal to 1, then it means events are mutually exclusive. If events are mutually exclusive, then what we are trying to say in essence is that the two events cannot occur together. Event cannot occur together. It's either one occur or the other one occur. Okay? And that is the reason why anytime we are talking about or in mathematics or in probability, we attract an additional rule. That we attract a plus. When I say it's either this or this, so it's either you are a male or you are a female. Now, the probability of a male plus probability of a female is actually going to be equal to 1. Because when I add male to female, I got the whole population. And what is the probability of a population? The probability of the whole population is actually going to be 1. That will be a sure event because at least you're actually going to have somebody that is a male or a female in a society. Are you guys hearing me?
Loud and clear.
Yeah.
Yes.
Okay, thank you so much. I just want to confirm that. Okay, now we want to go to the rules of probability right now. We're going to talk about, we got multiplication rule, we got addition rule, and so on like that. Now the question now is, when do we apply the multiplication rule? When do we apply additional rule? And so on like that. Now let me tell you something. You actually need to understand the rules in probability for you to be able to do well in probability. For instance, if I want to live in Minnesota, if I don't obey the rule in Minnesota, then I'm actually going to go to jail. If you live in any society, there's a rule that guides any society. Otherwise, somebody is going to be in trouble. And that is the reason why we actually need to understand the fundamental rules in probability. Now, if you take a look at what I have, when I say multiplication rule, oh, when do I apply multiplication rule? Okay, we're going to apply multiplication rule when events are independent. What do we mean by independent events? Events are said to be independent if and only if they can occur together. Okay? When events can occur together, then that is an independent. Then if I want to find the probability of the two events or occurring together, then I'm actually going to multiply the respective probability. That's exactly what I'm trying to do right here. If I'm looking for the probability of the joints between A and B, oh, this guy plays soccer. Oh, this guy also plays basketball. What is the probability that this guy play both? If I know the probability of the guy playing soccer and I know the probability of the guy playing basketball, then I'm actually going to multiply the two. That's a product. That's what we mean by multiplication rule. So multiplication rules applies to independent events. Now, I wanted to take a look at this. Right here, I'm talking about the probability of A, I'm talking about the probability of B. Those are marginals. These are marginals. But if you take a look at this guy here, I'm talking about the probability of B. Given that A has occurred, it means B is conditioning on A. Now, when do we say A and B are independent? You know, I said A and B are independent. We got three conditions for that, for A and B to be independent. But if you want to look at that from the English meaning, we're going to say two events are independent if and only if they can occur together. Now, if they can occur together, then it means occurrence of one does not depend on the other. That is the meaning. If the occurrence of one does not depend on the other, then the probability of B occurring given A will be equal to the probability of B. Because if the conditional probability is equal to the marginal, then we are trying to say there is no connection between the two. It means the two can occur together. It means one does not need the other one to occur. They can occur at the same time. Then it means they are independent. Independent means one does not depend on the other one. So mathematically speaking, when we talk about independent, because in a multiple choice question, let me just be telling you what you're going to, possible question in exam right now, because your exam is going to be a combination of a multiple choice and a short answer questions. Okay, what of in a situation whereby you are given something like this and they ask you to, to pick an appropriate answer. So this condition must hold. And you know what? In other words, the probability of A given B will be equal to probability of A, because A does not depend on B, because A and B can occur together. Okay, and don't forget that I said something the other time that, independence actually attracts multiplication rule. Now, I want to walk you through an example right now. Now, the joint probability of being male and having a blood type 0. To know that two events are independent, compute the marginal and conditional probabilities of one of them. If they are equal, the two events are independent. If not equal, the two events are dependent. Now, let me tell you this. Do you know that in exam or in a test or in an assignment, the examiner can actually ask you to investigate whether two events or whether two or more events are independent or not. Like I said, for those of you that want to leave the Zoom right now, if you have other meeting or you have nothing to lose, because I'm actually going to, this is being recorded, and I'm actually going to share that with you sometime, after the meeting. Okay, so for those that are leaving right now, please make sure you stay safe and do have a very good weekend for those that are leaving. Okay, thank you. Now, let me tell you this. If you want to investigate whether events are independent or not, then what you need to do is to compute conditional probability, and you need to also compute marginal probability. If marginal probability is the same thing as conditional probability, then you're going to conclude that they are independent. Independent. They don't depend. Now, let's talk about what is this. That's a marginal, right? The probability of being in blood group O, that's a marginal, right? And that is 40 over 100. You know what I'm talking about. If I take you back to the table, okay, You can see blood group O, how many? 40, right? Divided by 100. And that's why you get the 0.4, right? I'm going to show you now. That was why you got the 0.4 right here. Now, this is marginal. Okay? This is the probability of being in blood group O. Okay? Now, if I want to find the conditional now, the probability of being in, being a male, okay, and the person is in blood group O, given that, if you take a look at that now, this, if I want to check that now, this is what we did the other time, and what we have, we got the same results. 0.4 is 0.4. In a situation where your marginal and your conditional are the same, then your conclusion is actually going to be the two events are independent. Okay? Now, it is only when the marginals and the conditional are equal, but in a situation where the marginal and conditional are not equal, then you're going to conclude that they actually depend. And that was why we said then the two events are independent. And when two events are independent, you know what we talked about the other time? We're going to talk about the probability of interception. Independence, they can occur together, and if they can occur together, and that will actually lead to product rule, multiplication rule, then it means I need to multiply the probabilities of the two events. Take a look at this guy here. Probability of being in blood group 0 is this guy, and the probability of being a male is that guy. So I'm going to multiply that, and that will give me the 0.20. What have I done? Is 0.20 is a probability of these two events occurring together, being a male and belonging to blood group O. That's exactly. Is there anyone? Oh, okay. I'm not going to say is there anyone that have a trouble time because some people have left, but I'm actually going to. Okay, somebody says so. The probability of dependent events must equal to 1. I'm not gonna say the probability of dependent event must equal to 1 because you know why? If you want to use a value, if you want to interpret a value, it has to be the value you obtain from the process. Take a look at this guy here. 0.20 here means this is the probability of the two events occurring together. Okay, and if you 0.20 means what? That is 20%, right? That is more. That is 1/5. It means 1 out of 5. That may look so small. When the probability looks small, it means it may not likely occur. It may not likely occur does not imply that it's not going to occur. Does that make sense? Okay. Now, the next thing that I want to talk about now is we actually want to have a formula, okay, that will connect. If you take a look at the left hand side, if you take a look at this guy here, is a probability of A and B. We are actually talking about joint. Can you see that now? Now, when you take a look at what I have here, is just to multiply the probability of A by the probability by the conditional. This is just a rule. Okay. What I'm trying to talk about here is that if I have the probability of marginal, if I have a marginal probability, and I have a conditional probability, if I multiply the marginal probability by conditional probability, I can actually obtain the probability of the joint. Can you see that now? I can obtain now. Take a look at it. The probability of A and B will be equal to, when you come here, you're going to write the probability of A. And when you come to this side, you're going to write the probability of B, given that A has already occurred. So what I'm trying to give right here is just to be able to give a connection between the, the dependence and the independence. Okay. Now, if you take a look at this, if the probability of B given A is not the same as probability of B, then what we are trying to say is that A and B are not independent. Not independent means they depends. Look at two negative, not and in, those are two negative. Can you see that now? Now, what I wrote right now is a condition. Now, I'm going to give you an example right now. Let's say A is somebody that used to give me money. Okay? Let's say A is the event of somebody giving me money. And let's say B is living fine. Maybe my living fine. Now, if the probability of me living fine, okay, depending on somebody giving me money is not equal to my probability of living fine alone without getting money from someone, then it means I cannot live in isolation. I need that person. It means my living fine actually depend on that person that is giving me money. I'm going to say that again. Take a look at this. If A is the event of somebody giving me money to survive, and if B is the probability of me living fine, now if you take a look at this guy here, it means the probability of me living fine given that somebody is giving me money. And this guy here is a marginal. Marginal means I don't want to depend on anybody. Okay? Now, if the probability of living fine without that person giving me money is the same thing as the probability of living fine, even if that person is giving me money, then it means I don't need that person. It means I can survive alone. Then in that situation, we are independent. But in this situation, we are not. I depend on the person. You know, if you really want to understand your probability, if you want to understand anything mathematical concepts, you need to give your example. You need to be saying it. You need to relate to what happened in real life. Then you're going to understand it. Okay. This is another example. The joint probability of being ill and eat barbecue. Now, you know, what I'm trying to explain right here is this table. You know, I projected a table the other time. Yeah, this table right here. Okay, if you take a look at this table right here, we got two variables. Each of the variable are two levels. Look at that. Ate barbecue, did not eat barbecue, that's a variable, but that's at two levels. Okay, poison and not poison, that is another variable with two levels. So when you have a situation like this, you can actually compute, you know, an examiner can give you a table like this and ask you to figure out whether certain events are independent or not. And if you want to answer that, whether they are independent or not, then take a look at, I'm going to take you to the question right now. Now, if you take a look at it, this is the probability of ill, the probability of, you know, somebody gets sick. Now, how many people get sick? Let's go to the table. 110. Do you know the meaning of this 110? 110, there are some people, you know, it includes all people, those who eat barbecue and those who did not eat, that get sick. That is totality of those who get sick. And that is 110. If I want to know the probability of those who get sick, what am I going to do? It's actually going to be 110 divided by 200. Okay? Now, and that is exactly what I have right here. Look at that. The probability of somebody getting healed is 110 divided by 200. and that will be 0.55. Now, this is what? Marginal. Now, let us look at the conditional now. The conditional, the probability of getting sick, given that I ate the barbecue. Okay, now given that I ate a barbecue, then I'm actually going to go into that right now. Given that I ate the barbecue, how many people ate the barbecue? 90. Can you see that now? And that is actually going to be 90 divided by 200. And how many people get sick? 110. What is the probability of get sick? So, and that is the reason why you have this right now. You have 90 divided by 120. Now, compare this. Are they equal? Are they equal? No. So what are you going to say? If they are not equal, if the marginal is not the same thing as conditional, then it means they are not independent. The only condition for getting sick and eating barbecue are going to be independent is when you have the same value. And this is the way I want you to conclude in exam. Okay, you can see your argument right now. Then you're going to say, then the two events are dependent. Are dependent means they are not independent. Okay, therefore, if I now want to know, then the two events are dependent. Okay, the two events are dependent. Now, if I want to figure that out, you remember the formula that I gave you before. This formula right here. That's exactly what I'm going to use. The probability of A intersection B equal probability of A multiplied by that. Okay. Now, I'm actually going to do the probability of being ill, okay, intercept eating barbecue will be equal to the probability of eat barbecue multiplied by the probability of being ill given eating barbecue. Now I'm going to multiply that. Can you see that now? And that's going to give me 0.45. The 0.45 here indicates the joint probability between two events, getting sick and eating barbecue. So which means that occur how many percent? 45%. I think I'm actually going to take it so slowly. I'm going to stop here today because I know some of you may have other activity. And you know what? I'm going to, walk you through this gently. I'm actually going to, though I'm going to have a new material next week. But before I start the new material, I'm actually going to, start from here, the rules or the additional rule. We've talked about multiplication rule, then I'm going to walk you through additional rule. Now, on Tuesday, I'm actually going to have my office hour. If there is any one of you who need clarification on anything, please reach out to me. The fact that maybe if you have taken a probability course in the past, and you find it so difficult, believe that this time around, you're actually going to have an A. But the only thing you just need to do not hide your feelings. Okay? I'm ready, if you ask me a question, I can repeat myself over and over again. I'm comfortable with that. That's my job. Okay, so is there anyone who want to ask a question before I go today? Is there anyone?
I have a question.
Okay, go ahead.
So I suppose my question is more about the reading. Before next class, what reading would you like to be accomplished?
Thank you so much. Of course, this week and Monday next week, we are the idea is to cover chapter 2 of that textbook. So what I'm going to advise that you should read, you read all section in chapter 2 of the textbook. We are still on probability. Does that make sense to you?
Yep. Thank you.
Okay, you're welcome. And as practice questions, I said there is no assignment that is due for submission this week. But for some of you who want to have a practice question, something to practice, I'm actually, check the canvas tonight. I'm actually going to put some practice questions. You can attempt those questions. You don't need to submit. It's just for practice. Does that make sense? Okay, so is there any other person that want to ask question?
Will we have like a answer key for those questions or some kind of solution posted?
Okay, you mean answer key for the practice question that I talked about?
Yes, sir.
Oh, there's not going to be an answer key for now. You know what I want you to do? I actually, based on the knowledge, based on what you have acquired, okay, I want you to try those questions. Okay, when you try those questions, but you know what I'm going to do? I'm actually going to publish the answer key probably by next week. And you can now grade it yourself. It's going to be like a self, as kind of a test. Does that make sense to everyone? Okay, so is there any other person that want to ask question again? Please feel free to ask me question. Like I said, take me as your friend. I'm your friend, okay? So ask questions. Okay, in the absence of question today, I want to thank every other person, everybody, everyone that attend my lecture today. Like I said, I'm actually going to have an office hour on Tuesday. Please, you pay for this service. If any area is not clear to you, if you get stuck in anything, please reach out to me. I'm actually going to address that, please. I'm just begging everyone. You pay for the service. Okay, somebody said okay, I'm reading my chat. Somebody said I have a question. Why are there two? Oh, the person said, why are there two professors? Okay, you know what? The experience that I have in the spring, teaching from home. There was a time I was using my laptop and there was issue with the laptop. And that was the reason why right now, as I'm teaching, I'm actually, I'm conducting the Zoom on two different sources. So the moment one has an issue, then I'm actually going to switch to the other one. Okay, so have I answered my question now? That's a very, ask question. We are friends. Okay. I'm going to take one or two questions before I go again. Is there anyone want to ask question? Feel free.
I have a question.
Go ahead.
Are we going to cover a permutation and combination in this chapter?
Exactly. You're going to cover combination and permutation in this chapter. Yep,
okay,
you will.
Right. Cool.
Thank you. So is there any other person that want to ask question? Is there anyone? Feel free. I'm your friend. Ask question. Okay. In the absence of question, I'm actually going to thank. Somebody said, what part of Nigeria are you from? Of course, I'm from southwestern parts of Nigeria. But you know what? I'm from everywhere. Yeah. But originally from western parts of Nigeria. Yeah, Yoruba. Yeah, that is Yoruba tribe of Nigeria. But you know what? I'm from every nation in the world, but originally from there. Okay. I want to thank everyone once again. Please stay safe and do have a lovely weekend. Bye for now.
Thank you.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.